50 million years ago, Earth looked nothing like it does today. There was no ice, not at the poles, not anywhere. Palm trees grew in the Arctic. Alligators swam in polar waters. Carbon dioxide levels were 3 to 4 times higher than they are now, and a thick, humid heat covered the entire planet. What ended that heat was not an asteroid. It was not a supervolcano. It was a plant so small you could fit dozens of them on your fingernail. This is the story of the Azolla Event, one of the most consequential things that has ever happened on this planet. To understand how it worked, you need to picture the Arctic as it looked back then. The continents sat in different positions, and the Arctic Ocean was nearly landlocked, surrounded on almost all sides by land masses, with almost no connection to the wider ocean. That isolation created something unusual at the surface. Tropical rains from the surrounding continents poured enormous volumes of fresh water into this enclosed basin. Fresh water is less dense than salt water, so it did not sink or mix. It sat on top, forming a stable freshwater layer floating over the salt water below. That surface layer was warm, nutrient-rich, and bathed in 24 hours of continuous Arctic summer sunlight. The conditions were as close to ideal as a growing environment gets. One organism was about to make use of all of it. Azolla is a genus of floating freshwater ferns that still exists today. You may have seen it in a garden pond, a thin green film on the water. Most people walk past it without a second look. 50 million years ago, it changed the planet. What makes Azolla so effective is not the plant alone. Inside its tiny leaves lives a cyanobacterium called Anabaena azolae. This microbe pulls nitrogen gas directly from the air and converts it into nutrients the fern can use. In return, the fern gives the bacterium carbon and a place to live. That partnership produces a plant with no real nutritional limits. Azolla needs no soil and no dissolved nutrients in the water. Give it sunlight, water, and air, and it grows fast. Under ideal conditions, a mat of Azolla doubles its total biomass in under 2 days. In the early Eocene Arctic, those conditions existed everywhere. No predators, no competing plants, just warm, open fresh water and continuous sunlight. The fern did not just grow, it spread across the surface of an entire polar sea. What started as scattered green patches became an unbroken carpet covering thousands of kilometers. Generations of ferns grew, doubled, and died in rapid cycles. When they died, they sank. The deep water in this enclosed basin was completely anoxic, meaning it contained no oxygen. No bacteria could survive down there, and nothing could decompose the dead plant matter. So the ferns did not rot. They sank, settled on the seafloor, and stayed there, layer after layer. This was not a brief episode. It ran for approximately 800,000 years. For close to 1 million years, the Azolla mat pulled CO2 out of the atmosphere, locked it into plant tissue, and buried it on the ocean floor. The physical record of that process still exists. Geologists drilling sediment cores from the Arctic floor have recovered fossilized Azolla layers up to 8 meters thick. You are looking at a direct record of a climate shift preserved in the sediment. Scientists estimate the fern sequestered trillions of tons of carbon during this period. Atmospheric CO2 dropped from around 3,000 parts per million in the early Eocene to roughly 1,500 parts per million or less by the end of the event. That is not a minor shift. It is the difference between a greenhouse planet and the climate system we live in today. As CO2 fell, the climate crossed a point it would not return from. The Arctic stopped warming, palm trees at the poles disappeared, global temperatures dropped. Earth began its long transition toward the icehouse conditions that produced the first permanent ice sheets on Antarctica. In ending the greenhouse world, Azolla also ended itself. As the climate cooled, the rainfall patterns that had been feeding the Arctic freshwater layer weakened. Ocean currents found paths through the continental barriers. Salt water mixed into the fresh surface layer. The conditions that had made the Arctic a paradise for Azolla collapsed. The great polar fern mats broke apart and vanished, leaving nothing visible at the surface. Only those thick, organic sediment layers at the bottom of the ocean remain as evidence. The Azolla Event makes a specific point about how this planet works. Most people think of climate as something shaped by geology, plates moving, volcanoes erupting, continents drifting. Those forces are real and they matter, but life is also a geological force. A fern and a bacterium, working together at a microscopic scale over hundreds of thousands of years, shifted the climate state of an entire geological era. No asteroid required. When scientists study those fossilized layers today, they are not just examining an old curiosity. They are working out how carbon cycles actually function, how living systems interact with the atmosphere, and how small organisms can tip a planet from one climate state to another. The Azolla Event shows that large-scale change does not always come from large-scale causes. Sometimes it comes from something too small to see, doing one simple thing for a very long time.